we're going to write the name for this compound and identify the number of pi and sigma bonds that are present in it. In this stick figure model, we do not have the hydrogens drawn, and it is a two-dimensional image here. So I recommend you build these things with your model kit. So here I have this 6-carbon ring here, and I have this triple bonded kind of tail wagging off here. Note that this is not flat. There is a puckering in the ring. You push these bonds in here. There's a puckering. You see this one right here kind of flips up, and it can flip down. Very similar to and this one can flip too, so we kind of have a chair, a boat, a twist, all that stuff going on in there. This can rotate freely, and this can rotate as well right here, these sigma bonds. To name this right here, we want to pick the most interesting thing about this molecule right here that contains the most carbons. Two things I highly recommend you get used to doing: reading the names backwards and counting your carbons. So let's start by counting our carbons. We have how many carbons in this structure here? Did you get them all? 9. Kind of hard to see, but there are 2 carbons here in the stick figures, but in the model, it's easy to count. 1, 2, 3, 4, 5, 6 in our ring. 7, 8, 9. 7, 8, 9. Let me try to orient it like that there. Okay, so we have 9 carbons. Got to remember that. Most interesting thing in our structure here is the cyclic molecule right here, and it is a cyclic ene. So cyclo, 6 carbons. Cyclohexene. Now, when telling the reader where this double bond is, we have to give it a locant. We want to give it the lowest number location as possible. So we have to be able to start at one of these carbons, count across the double bond, and then get to the next most interesting thing here. So there's 2 directions we can go. The shortest route would be to start here and go 1, 2, 3. 1, 2, 3. Now you may say, wait a minute, what if I just went here and started this as 1? The rule is, the grammar, the hieroglyphics, the codex of chemistry is that we count across the double bond. So if you started here and went 1, 2, I would say those are lower numbers, but it doesn't fit the grammar. So 1, 2, 3. If you were to count the other way, clockwise, you would say 1, 2, 3, 4, 5, 6. That would be, I would say it's a good answer, but not the most grammatically correct answer. Because if you started here at 1 and counted clockwise, you would still be able to accurately reproduce the picture, but it wouldn't be the best answer. So here's our locations: 1, 2, 3. We don't have to tell the reader that the double bond is on the 1. That's implied. I'm going to put it in there anyway. 1 cyclohexene, just for my own right there. There's nothing wrong with that. Now on the 3 location, there's this thing that dangling off. Let's put a 3 right there to say that it's on the 3. Now, what's in this right here is a prop-ine substituent. So prop for the number of carbons, and then wine or ine to indicate the triple bond right there. Now, here we have the number of carbons in our name. 6 plus 3 equals 9. We gave a location of this double bond. We need a location of this double bond. So in counting the substituents, we count closest to the most interesting thing. So this is 1, 2, 3. So this double bond is on the, this triple bond is on the 2. So this is a mouthful here. 3, 2 propine, 1 cyclohexene. That is a good name for this compound right here. Now the type of bonds that are present in here. There's a lot of sigma and a couple pi bonds that are present. Now the sigma bonds are just one line that are shown. And remember, in this picture and also in this model, I don't have the hydrogens present. So let's just kind of let's talk about the number of carbon-carbon sigma bonds, carbon-carbon pi bonds that are present right there. So the carbon-carbon sigma bonds, make that symbol a little larger, the carbon-carbon sigma bonds, we can count them in each of these structures. The first bond any atom forms is going to be a sigma bond. So in this ring here, there's one, 2, 3, 4, 5, 6. 6 sigma bonds here, 7, 8, 9. There are 9 carbon-carbon sigma bonds. Now the carbon-carbon pi bonds, the second and third bonds between carbons are going to be pi bonds respectively. So right here there are 2 bonds. One of them is a sigma and the other one is a pi. I'm arbitrarily assigning one of those lines as a sigma and one of them as a pi. You could flip it right there. It's up to the reader to make that kind of distinction there. You know, to kind of say, okay, one of these is a sigma, the other one must be a pi. That's what the author is implying. Up here with this ein, one of them is a sigma, and I'm just going to say the middle one arbitrarily, and the other 2, they're pi's. So there are 3 pi bonds in this structure here. Thank you.